equations for isometries. Amazingly enough, by the end of that podcast, we'll be able to write equations for any isometry in the plane. Last time we classified isometries, worked with conjugations, figured out dihedral groups, did many things, but today we'll finally get the explicit equations for any isometry. So let's start with equations for rotations. How do we figure out equations for rotations? Why? Because equations for translations, of course, are easy enough. They were included in the definition of the translation. Of course, we remember them, right? What are the equations for translation? Equations for reflections we figured out. They were quite complicated. You don't have to memorize them. So we already have done that. No need to memorize. Every time you need to do a reflection, you can figure it out from the lines, from perpendicular bisectors. And also we saw the equations for half-turns. But these are specific kind of rotations. We want today to start with finding equations for a general rotation. Before we tackle the general rotation around arbitrary center and arbitrary angle, let's start with a rotation about the origin and with an angle of theta. So we are looking at the rotation about the origin, 0, 0, at an angle of theta. Of course, we would like to write it as a product of two reflections. In which lines? What are the good lines to put in there? What do you think? Well, how about x-axis? Line H followed by a reflection on line L, which is directed angle of theta from H, correct? Wrong. Exactly what's wrong? H over 2. Now it's correct. So how do we figure out the equations for these? We will need to, since we know the equations for each of those reflections, then we can just compose them and write the resultant equation for the rotation. No big deal. So let's start with the most complicated of the two, with sigma L. Of course, the equations for the sigma H are quite easy. We'll be able to add it at the end as an afterthought, but let's start with equations for sigma L. So what are the equations for sigma L? Well, as I've told you, you don't have to memorize them because I memorized them for you, but you can write them as x prime y prime equal x minus 2a over ax plus by plus c over a squared plus b squared. And this one is y minus 2b ax plus by plus c over a squared plus b squared. So what are those a, b, and c? Of course, pause and think. Right? Those are the coefficients in the equation of the line L that we are looking at. So for general reflections, if L, these are the equations, if L, is given by ax plus by plus c equals 0. Fine. So in our particular case, we just have to figure out the equation of this line L then. What is this equation? Any idea? So equation of line L. Equation of line ax plus by plus c equals 0. What are a and b and c? So pause for a second and think. Come back. You have an idea? Well, it's definitely an equation through 0, 0, equation of the line through 0, 0, and you know the slope. So that's one way to attack it. There are a number of ways to obtain this equation, but basically what you do know is that length 1, unit length from the origin, there lies a point on this line with coordinates. What are the coordinates? Sine and cosine, right? Sine theta over 2, cosine theta over 2. Correct? No, of course, wrong. What's wrong? Pause, come back, figured it out. Exactly, I switched them around. X coordinate is the cosine and Y coordinate is the sine. So cosine theta over 2, sine theta over 2. I mixed them up, so now it's correct. And looking at this, you can, for instance, get a slope, and you can draw the line through the point 0, 0 with the slope that you can easily get. So as a result, you should get what kind of line? As a result, you should get minus sine theta over 2x plus cosine theta over 2y equals 0. So that is the equation for the line L. All right, so if that's the equation of the line L, then we can easily write down, fill in the blanks, since this is our A, this is our B, and C is equal to 0. We can fill in for A, B, and C these coefficients and get the equations for the reflection in line L. What are they? Let's work it out. So again, good exercises to stop the podcast and figure it out on your own. Come back, and all right, I'll figure it out in detail in case you want to check your calculations. So we'll just write x prime equals and y prime equals. So we have to write x minus y minus 2 times a, so we have plus 2 sine theta over 2 times ax plus by plus c, so we just repeat this equation, minus sine theta over 2x plus cosine theta over 2y divided by a squared plus b squared. So a squared plus b squared is of course what? Correct, 1. That's it for x. For y we will have minus 2 times b. b is cosine theta over 2 times, again, the same numerator, right? Same, I forgot x, sorry. Same denominator, 1. All right, I hope you can see. It's a little bit. Let me get a good eraser. So maybe I'll erase this. Okay. So I can also erase the equation for the general reflection. And we're just writing in case of our line has this particular shape. So let me just check if anything is messed up. Everything is correct, and well, I will simplify a little bit here. X prime equals, so we have 1 minus 2 sine squared theta over 2. So x times 1 minus 2 sine squared theta over 2. And here we have 2 sine cosine. Sine theta over 2 cosine theta over 2. Remember the formula for the double angle. Sine of an angle times cosine of an angle twice. It's exactly sine of a double angle. So we have plus sine of a double angle theta times y.